Hey everyone, my name is Kunal Anand. My student ID is S224704431. In this project, I explored and modeled a sample of red wine dataset. The goal was to predict the alcohol content using a various physical and chemical properties of the wine. I followed a step-by-step process from exploring the data, transforming it, building model, and finally making prediction. Data sampling and variable selection. From the original dataset of 599 samples, I randomly selected 460 using my student ID as seed. I focused on six important variables. Scatter analysis. I created scatter plot to see how each variable related to alcohol. Some showed clear trends, while other did not. For example, citric acid and pH had weak relationship, but chloride showed a positive trend. This helped me understand which variable might need transformation before modeling. Data transformation observation. Many variables were skewed. Citric acid, chloride, and sulfuric dioxide were right skewed. pH was slightly left skewed. Alcohol looked closer to normal. So I applied transformation like log, negative, and square root to make more symmetrical. Then I used min and max normalization to bring everything into same range. Skewness based data transformation. To make data suitable for modeling, I checked the skewness values using R's E107 package. I transformed highly skewed variables with the log or negative transformation and used square root for mild skewness. This step helped improve model accuracy by making the data more balanced. Normalization and exporting data transformation. I used min and max normalization to scale all the values before 0 to 1, 0 and 1. This makes sure no variable dominate during the model. I saved transform data, scatter plot after transformation, predictive versus alcohol after transformation and scaling. The scatter plots looked much cleaner. Outlier had less effects and some patterns were is clearly visible, especially for citric acid and pH. This showed the data was now more ready for modeling. Transformed variable distribution. Here you can see how the transformation improved the distribution. Most variable now look more symmetric, which helps the model learn better. I used histogram to double check the result. Model evaluation matrices. These are the matrices of all uh, models, and in this uh, their insights. I use four different aggregation models to predict alcohol content and compared them using error and correlation matrix. RMSE, and average absolute error measures how accurate the model is, while Pearson and Sepperman showed strength of relationship. The QWM model give the best performance overall. Important of selected variables, I choose citric acid, chloride, total sulfur dioxide, and pH because they play a big role in fermentation process. This factor affect freshness, stability, and quality of the wine, which directly impact the alcohol content. Best fitting model for prediction. Based on the result, the P2 model or power mean 2 model was the best. I used the new values for these variables. These were transformed and fed into model to predict the alcohol content. Prediction, result and reasoning. The P2 model predict an alcohol content of around 3. After reversing the normalization, I found that the result fits within the expected range from the dataset, so the prediction is realistic and reasonable. Implication, limitation, and ethics. This model can help estimate wine quality based on chemistry, but it has limitations like assuming the data patterns always stay the same. Ethically, we must be transparent about model performance and protect any personal data used during the analysis. Thank you.